left off with the empirical rule. We have this past the pigs where we've got our frequency right here. Did we do anything with this? Did we find relative frequency or anything like that? So this one is the same thing as finding the relative frequency when we're finding the probability. So let's see. It says use the results to build a probability model. When they say probability model, they really just mean give the relative frequency. So what I'm going to do, I don't think I left a whole lot of room on the side right here, but I'm just going to tack on another column to my chart over here where I just write out the probability. So marker. So for each outcome, I'm going to determine what the probability is. And it's not going to be, 1 out of 6 the way it is with a regular die, because you can see this side with no dot happened a lot more times than this thing down here, the leaning jowler. So when we use the empirical probability, we're going to be using the relative frequency. So I've got my calculator with me. So So altogether, we've got 3,939. Actually, that's how many times it was rolled all together. So here to get your probability, it's the same thing as your relative frequency. So your probability is just going to be, for this one, 1344 divided by 3939, 1294. When they ask you these ones on the homework to build a probability model, they just mean for each outcome, go ahead and put the relative frequency or probability into the blank with a little table. So it should look familiar to what we did in chapter 2. That's the first part, building a probability model. That's all you have to do is just figure out the probability for each of these things using the empirical rule. So we're just basically using relative frequency for those things. All right, and then for part B, it says estimate the probability that a thrown pig lands on the side with dot. In this case, when they say the direction, they say estimate because you can't really know for sure. If you look back at the formula that we had, the probability is approximately equal to the relative frequency. That's going to be our estimate. It's not going to be exactly that. We don't know what it is. So when we use the empirical approach, it's always going to be an approximation. The more number of trials you have in your experiment, the better the approximation is going to be. So having a high end, which is a pretty big thing, means that this is going to be a pretty good estimate for us. So for us, for this one, if we want to find the probability that the pig lands on a side with dot, what would that be? Yeah, that's just going to be the relative frequency, which is 0.329, and that's going to be our probability, and that's all we have. And then the last part, part C, it says, would it be unusual to throw a leaning jowler? Would you consider that to be unusual? No? No? Yes? So it's been a week, longer than a week. But remember this term right here where it says unusual? When we refer to something as being unusual, the probability has to be less than what? 5%. So unusual is going to be less than 5%. So if we look here at leaning jowler, this is 0.008. If we move the decimal over, it's 0.8%, which is really small. So in this case for part C, we would say yes, because the probability of a leaning jowler equals 0.008, and that is less than 0.05. So when you have those types of questions, it's not a yes or no question. You have to figure out what the probability is first and then compare it to 0.05. When they go through here's our probability, and then they go through and just interpret it, same as we did last time. We did the classical approach last time, right? We started with that? Okay. So with this one, it says, if 1,000 throws of the pig and 1,000 throws of the pig, we would expect 329 to land on a side with dot. Remember when we did the other example, what we did was we just took this, how many trials we have, in this case it's 1,000, multiply it by a probability to get this number right here. So that's how they found that. And then for the other one, with the leaning jowler, they did the same thing. They took this probability, they multiplied it by 1,000 to get 8. And that's how many times you would expect to see a leaning jowler out of the 1,000 times it was used. So that's usually going to be a follow-up question for these types of things.